Hi, I'm Dr. Fox, and let's discuss the gallbladder and biliary tree. In this video, we'll discuss the location, structure, function, and blood supply of the gallbladder. We'll also discuss the variety of origins and pathways of the cystic artery. And we'll outline the biliary tree, that is the pathway of ducts and openings that bile takes between the liver, the gallbladder, and the second part of the duodenum. So let's start with the gallbladder. The gallbladder is generally an intraperitoneal organ, so it is covered by parietal peritoneum, but it may also be intrahepatic, so it might be nestled within the body of the liver itself. Quite simply, the gallbladder is a storage sac for bile. It has a fundus, a body, and a neck, and it is going to connect via a cystic duct to the remainder of the biliary tree. We can see the proximal parts of the biliary tree here, these right and left hepatic ducts and this common hepatic duct. And so bile follows this pathway down and then flows retrograde into the gallbladder for storage. The gallbladder is served by the cystic artery. Sometimes bile can associate with other substances to solidify and create bile stones, which can be very painful. The treatment for which might be really conservative, so a doctor might just allow you to pass bile stones, or if it's very severe, they might choose to remove the gallbladder, in which case a cholecystectomy is in order. And in order to do that, the surgeon will have to ligate or tie off the cystic artery, which is the main blood supply for the gallbladder. So it's important that we understand where the cystic artery comes from and where it can reliably be found. Typically, the cystic artery is a branch of the right branch of the hepatic artery proper. So here we can see the hepatic artery proper coming from the common hepatic artery. There's a left branch and a right branch of that. And 9 times out of 10, the cystic artery originates from that right branch. But it may also come from the left branch of the hepatic artery proper, the hepatic artery proper itself, the gastroduodenal artery, any of the celiac branches, or the superior mesenteric artery. So there is a variety of places from which the cystic artery may arise. But there is only one reliable location to find the cystic artery, and that is in the hepatobiliary triangle. The hepatobiliary triangle is a space prescribed by the visceral surface of the liver superiorly, the common hepatic duct medially, and the cystic duct inferolaterally. So always will the cystic artery move through that hepatobiliary triangle. So that is how a surgeon can find the cystic artery for a cholecystectomy. So let's take a look at that hepatobiliary triangle specifically. So we've got our visceral surface of the liver, common hepatic duct, and the cystic duct. And so mostly it will come from the right branch of HAP, but we know that it could come from a lot of different places. It goes through that triangle on its way to serve the gallbladder. Let's look at the proximal biliary tree. The biliary tree begins in the liver as intrahepatic ducts that are draining bile canaliculi, and these are going to condense into either right or left hepatic ducts that exit the liver. So here we can see the right hepatic duct and the left hepatic duct that will coalesce into the common hepatic duct. That common hepatic duct is going to join the cystic duct. So bile can drain from the liver down those ducts into the gallbladder. Bile can also then move from the gallbladder down the cystic duct back towards the biliary tree, or the remainder of it, into what's known as the common bile duct, or just the bile duct for short. So this is the proximal biliary tree. Let's look at the distal biliary tree. So we have the common bile duct descending down, and that's going to be in the hepatoduodenal ligament. And that common bile duct is going to join the main pancreatic duct, so bile joined with pancreatic enzymes, into a region known as the hepatopancreatic ampulla. So that hepatopancreatic ampulla is an expansive space that's going to feed into the major duodenal papilla, that eruption of mucosa in the second part of the duodenum that marks the transition between the foregut and the midgut. So we have these accessory organs, the liver, the gallbladder, and the pancreas, that are associated anatomically with the foregut, but their functions are associated with the midgut. So anatomically, foregut; physiologically, midgut. So we've discussed the location, structure, function, and blood supply of the gallbladder. We've discussed the myriad of origins and the pathway of the cystic artery and why we would want to ligate that for a cholecystectomy. We've also outlined the entirety of the biliary tree, both the proximal and distal pathways, as well as where that biliary tree joins with the main pancreatic duct through the hepatopancreatic ampulla, through the major duodenal papilla, and into the second part of the duodenum. Thank you so much for your time, and I look forward to talking to you later.